Hello everybody, welcome back. This is lesson 7 of unit 10. Today we're going to talk about acid-base indicators. The best way to go about this lesson is to watch this video as you are following along with the note sheet. As of right now, it looks like there is the pH scale indicator castle learning that is due tonight. Again, just double check on the calendar because that is the go-to thing. From the day I make this to the day you watch this, things might change, but the calendar will be updated, so check there. So again, today we're going to talk about indicators. Yesterday we talked about the pH scale, and now if you want to determine what a pH is, indicators can help with that. So table M on your reference table has all the indicators that you need to know, and we're going to talk about how to use this table. So an indicator is a valuable tool for measuring pH because when it's in an acid, it's one color, and when it's in a base, it's a different color. So based on these color changes, and we kind of alluded to this in the first or second lesson of this unit, that this can help with pHs. So the first one is methyl orange, and it is red if you have a pH of 3 or less. It is yellow if you have a pH of 4 or more. And if you're in the middle, you have a pH, if you're in the middle between of that range, you're orange. So how this works, this first number and everything lower, you're red. So anything 3.2 and lower, that means you are red. That second number and higher, that means you are the second color. So if you're 4.4 or bigger, you're yellow. Now if you're in that middle range, you're kind of a mix in between the colors. So the middle of red and yellow is orange. Phenolphthalein is something we had briefly mentioned before. It's something you've used in living environment, I think. So 8.2 and lower, it's going to be colorless. If you are, this is, sometimes it's 9, sometimes it's 10. It's not, indicators aren't a perfect go-to, but 9 or 10 and higher, you are pink. If you're somewhat in the middle, you're a very, 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 very pale color. Okay? With litmus, there's a bunch of different litmus papers that exist, but we're just going to focus on this. If you have a pH of 5 or less, you turn red. So blue litmus paper will turn red if there is an acid. Red paper turns blue if it's base. So if it's 8.2 and higher, it can turn blue. There's also litmus paper that is universal, so it does all of the pHs, and it has a specific color for each thing. But you won't need to worry about that unless it tells you, but then it will give you the colors that you would need. Here's some basic humor. Let that sink in for a second. Okay, moving forward. Bromcresol green. If you are 3.8 and less, you are yellow. If you are 5.4 and higher, you are blue. If you're in that middle section, you are a mix between those two colors, and that is green. Thymol blue. If you are a pH of 8 and less, you are yellow. If you are a pH of 9.6 and higher, you are blue. And then it can even turn red if you have very, very acidic solutions, but you're not responsible for that at all. Now, you can make indicators at home. If you have red cabbage, you can chop it up, boil it, strain it, and use it as an indicator. And then this kind of tells you what color things may be. And depending on the color, it depends on what the pH is. So if you have red cabbage at home, this is a pretty cool, pretty safe experiment too. Okay, so you can use more than one indicator. So to figure something out. So if we're looking at, let's say, methyl orange for a second. If it's yellow, that means you have a pH of 4.4 or higher. Well, cool. That narrows it down not very well at all, because it could be 4.4, 4.5, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. That doesn't help. So most of the time, people will use more than one indicator. So if we're going to look at this, if you put Bromcresol green in a solution and it turns blue, that means it's pH of 5.4 or more. Okay? So Bromcresol green is this one. If it's blue, it's 5.4 and higher. You still have all of the number line left. Now, if you put Thymol blue in another test tube with the same solution, it turns yellow. So that means it's 6 Thymol blue. Turns yellow, it is 6 and lower. Okay. But now you can put those two things together. So you know it has to be bigger than 5.4, but also has to be lower than 6.0. So you want to look at where those two things overlap, and then you're like, oh, well now the pH has to be between 5.4 and 6.0. That gives you a much better value of what the pH could be, rather than just, oh, it could be anything between 5 and 14, because that does not help. So let's try this one. You have a mystery solution, and it turns Litmus red and is yellow when methyl orange is added. So Litmus is red when you have a pH of 5.5 and lower. Methyl orange is yellow when you are 4.4 and higher. So I like to use the number line. So 5.5 and lower. And then you have 4.4 and higher. So now you know that you have to be somewhere in between 4.4 and 5.5. So your pH will be between 4.4 and 5.5. That's a much better range than just bigger than 4 or less than 5. Okay. Mystery solution number 2 is pink when you're using phenolphthalein. So that means phenolphthalein. If you're pink, means you're 10 or higher. And it turns litmus paper blue. So it's blue when you are, nope, wrong one, litmus, 8.2 and higher. So if we put it on our number line, we have 8.2 and higher, and we have 10 and higher. So you want to look at where those two lines overlap, and that's from 10 on. So here our pH can be between 10 and 14. So in this specific example, we didn't get as small of a range, and that's sometimes the case. More indicators would have to be used. Okay, so just to kind of sum this up, acids have a pH of lower than 7. Litmus turns red, phenolphthalein is clear, Thymol blue is yellow, and methyl orange is red. And then, oppositely speaking, bases are higher, have a pH of 7 or higher. Litmus is blue. Phenolphthalein is pink. Thymol blue is blue. And methyl orange is yellow. So again, you don't need to memorize any of this. It is on the reference table. So I want to show you this quick video first. Watch and then we'll talk. So this is a lovely video with the name video. When you first started it, it was purple. So that floating thing is dry ice, which is frozen carbon dioxide. And it turns directly to a gas. So that phase change from a solid directly to a gas is sublimation. That is what that looks like, in case you were curious. So what happens if we're inside this tube, we have something called universal indicator. So it allows you to kind of track the pH change. So things towards the end of the rainbow, like purples, blues and purples are kind of your basic things. Green is essentially where your neutrals would be, and then your warm colors, your red, orange, yellows, are your acids. So knowing that, we're starting as a base, and when you put that dry ice in, it releases carbonic acid, and then you can see the pH change. The pH changes because the color changes, and it goes through the entire rainbow. So it goes from a very basic solution. If you let this sit for long enough, it turns very, very red, and that means you have now a very acidic solution. That was my hand that actually dropped that dry ice. It is very exciting. Okay. So, just kind of going over this. Again, universal indicator was used, so it kind of follows the same pattern as up here. Red is when it's acidic, purple is when it is basic. So we can say that the pH went from a basic thing to an acidic pH. And so when you're becoming more acidic, that H plus increases. Okay, so let's wrap it up with 5 summary questions. If an aqueous solution turns blue litmus red, so that means you are going to be an acid. Which relationship exists between the hydronium? So hydronium is H3O plus. Hydroxide is OH minus. That is on table E, the polyatomic ion table, in case you forgot that. So how are those two related? So if you're an acid, that means you have more H3O plus. And so that is what this first answer is saying. So A represents an acidic solution. B says you have more OH, and that's basic. C says you have equal amounts, and that is neutral. And again, that exponent is your pH, so a pH of 7 is neutral. D, this exponent of 14 doesn't make sense. That doesn't even exist, so that's a hard no. Okay. Next. In which 0.01 molar solution of is phenolphthalein pink? So phenolphthalein is pink in a base. But if you're given these 4 things, how are you supposed to know if something is basic or not, or has a pH of 10 or higher? So you want to look at table K. This has K and L. One of them is acids, one of them is bases. And so if we're looking for something with a pH of 10 or bigger, that is a base. And according to those tables, the only thing that is a base is choice B, calcium hydroxide. Okay. Next one. It says red litmus is blue, blue litmus is blue, phenolphthalein is pink. So all of these, again, you have to be using table M for your indicators. Say that this formula has to be basic. Again, you want to look at tables K and L for acids and bases. C and D are different kinds of sugars. A is your acid on table K. This NaOH is your base on table L. So that means A has to be your answer. Okay. Moving forward. Checkpoint question number 3. 3 samples of the same solution are tested, each with a different indicator. All 3 indicators, bromothymol blue, bromcresol green, and thymol blue, appear blue if the pH solution is. Okay. So there's a lot to unpack here. Bromothymol blue is blue when you have a pH of 7.6 and higher. Again, you have to look at table M for this. I'm not just making this stuff up. Bromcresol green, Bg, is blue when it is 5.4 or higher. Again, it's straight from table M. And then thymol blue is blue when you have a pH of 9.6 and higher. So let's add this to our number line. So we have 5.4 and higher. That does not help. Well, we know now, no, it can't be A. It has to be bigger than 5.4. Next we have 7.6 and higher. Okay, so it can't be B. Now we have 9.6 entire. So the spot where all three lines coexist, it is 9.6 or higher. The only one bigger than 9.6 is D, 9.9. Okay. Lastly, number 5. Which statement correctly describes a solution when you have a pH of 9? So a pH of 9 means you are basic. And if you're basic, that means OH is bigger. You have more of it than H+. And again, that's the same as H3O+. And then if we just kind of skim the questions, we're talking about litmus, methyl orange. So, in a base, methyl orange, well, hold on. It's saying methyl orange is yellow, is red. So, methyl orange is red, and it's acidic. When litmus is blue, that's basic. So if we look through these answer choices, the only one that, well, we know because it's a pH of 9 or higher, that OH is more than H3O+. So we can get rid of A and C. So we focus on B and D. This says methyl orange is red, litmus is blue, so that's where this comes into play. Methyl orange is red if it's an acid, and blue if it's basic. So the only answer that makes sense is B. So that is it for acid-base indicators. Tonight there is a class learning to kind of review this and yesterday's material. Hope this was helpful. On that note, have a wonderful day.